I decided that a short video might be the best way to show off some of the highlights of the course materials I'm generating and try to point out what I think might make them unique. The original site is ee.hvullc.com. It contains a lot of early development work in the context of an Introduction to Electric Circuits class. We're updating the materials to a new format, and I'll create a video for that site later, but this site has the most features currently implemented. To try things out, I'll click on Try as Demo User. My primary goal with these sites is to help motivated students to learn. This results in a wide range of activities. There will be textbook materials and lecture videos, which is typical for these types of sites. The practice problems on this class are the heart of the site. Many sites have problems for students to work, but I provide a wider range of problem types than is typical. My secondary goal is to avoid student frustration. Frustration is usually caused by non-productive time spent on task. So I've tried to make it difficult for students to get stuck. What I'm not explicitly trying to do with this site is to give students a grade. As an example of what I'm talking about, let's take a look at a problem from Lesson 8 in Unit 1. I'll look at problem 1.8.5. This is a simple question, as most of the questions are in the first couple of units. We're given a current, 3 milliamps, through a resistor, which is 1.5 kilo ohms, and asked for the voltage difference. Voltage is just the product of resistance and current, so 3 milliamps times 1.5 kilo ohms will be 4.5 volts. That's flagged as being correct. This site is somewhat unique in that most of the problems check to see whether the user's solution is mathematically the same as the correct answer, rather than whether the actual values match. Let's try this problem again. I'll exit that problem so that everything's wiped out and go back to it. Since voltage is the product of current and resistance, I could say that this is 3 times 1.5 kilo ohms. 3 times 1.5 is 4.5. That's numerically the same as my previous answer. I could get rather silly and say 4.5 is 4 plus 1/2. Anything that evaluates to 4.5 will be tagged as being correct. Let's exit and come back to this problem yet again. Now if I put in a wrong answer, that's tagged as incorrect. If I submit a wrong answer more than 3 times, I get the option to give up. So this will give me the correct answer, so I can't really get stuck. Along with an ability to just give up, I've tried to make it easy for students to get help without necessarily giving up on everything. The problems in Unit 1 are pretty simple, so let's go to Unit 2 to take a look at getting help. In Lesson 2.6, I'll look at problem 2.6.3. We want to find a voltage V. This one has a help button as well as a submit button. If I ask for help, a window opens up here. Many of the help options support multiple solution approaches. Let's try solving this problem using a current divider. This will walk me through a series of steps that lead to a current divider-based solution for the problem. I'll just give up my way through the problem. So step 1 is to determine the total resistance. Step 2 is to find the current out of the source IS, which is 3 amps. Step 3 is to use a current divider to find that current, and then finally Ohm's law gives me the value of voltage, 2 volts. Let's get out of this problem and come back to it. Need to visit another problem for it to clear out all of the data from the previous try. One of my main goals is to help students explore and learn and try to identify a solution that requires the least amount of work. If I go to help and hopefully now try a voltage divider solves this problem in 1 step. A fairly common thing that people say to me at this point is that it's too easy for students to give up. They don't have to engage in anything. My answer to them on this is twofold. First, I'm mostly interested in helping motivated students. If you don't want to learn, you're just not going to learn, and there's nothing I can do to help. Remember that I'm not trying to give students a grade with this material. I'm just trying to help them learn. Although I don't really want to give a grade, I do want to give students feedback about how they're doing. These metrics have not been implemented yet, but the algorithm will essentially provide very little credit for passive activities like watching a video or reading a textbook. No credit at all is provided when students give up their way through a problem. There will be partial credit if you get some steps right in the help windows, of course. The plan is that if students have to give up or get help, they use that as an active learning experience and then try a similar problem. Resources for doing a problem that's similar to the one that they're working on are under the Related Materials tab. So this takes me to a related practice problem, 2.6.4. Hopefully if I can do this one, then this will help me do the one that I'm working on now. The related materials will also allow me to look at lectures or see examples. So this is a video of an example of a similar problem. One other metric for assessing student performance will be that looking at related material does not reduce the credit you get for the problem. So if you're stuck, you can look at an example or work a related problem and then come back to the original problem without penalty. I've shown that the help tool can support multiple solution approaches. However, sometimes the necessity of making a decision is built into the solution approach itself. Examples of this type of thing are nodal and mesh analysis. Nodal analysis is in Unit 3. If I go to some of the practice problems down here and look at 3.4.1, I'm given a circuit with nodes defined. In nodal analysis, you have to start by classifying each node. The equations you write and solve are then based on that classification. I'll choose A as an independent node, B as a dependent node, C as an independent node, and D as my reference node. The site provides you with a schematic that shows your choices, and it prompts you to do KCL at node A and C to get the two equations that you need to solve. I'll just give up through this. Those are my answers. Everything's in symbolic form, so I don't have to worry about the students making silly arithmetic mistakes and thinking that that means that they don't understand the approach. These symbolic expressions are also checked for mathematical equivalency. If I copy this equation, Control C, and then go out of this problem and come back to it. Now if I paste this equation in here, let's change this around so it's the same equation but it looks different. I'll change the sign on this term, make this VS minus VC. Notice that there's a keypad here that lets me choose variables. If I submit this, this has a green box around it. It's still correct. This is incorrect because nothing's entered. So students can set up their own sign conventions and solve the problem correctly without it necessarily exactly matching the sign convention that I use to generate my solution. Now let's take a look at some of the other materials that are on the class site. I've already mentioned quizzes. Most of them are not populated at the moment. If I were to use this site as a component of a graded class, I would probably weight the quiz problems more heavily since they will not contain give up options. Finally, students like to see examples. These lecture videos introduce concepts and typically provide an example or two of those concepts. Lots more examples are available in the examples links. Let's go to Unit 4, which is mesh analysis. Take a look at the examples here. As usual, I try to support multiple learning styles. So the solution might be in terms of a PDF of a written solution. That's another PDF. Some of the solutions are in the form of videos. And in some cases, I try to show more than one solution approach. So this particular problem, I give two possible solution approaches. One of them is in video form. The other one's a PDF.